In our last video, we're going to look at from this chapter is called the deceptive graphs. So as you know that a statistic can lie. So the reason it can lie because when we are creating this kind of visualization, people can manipulating it, or we are given the manipulated data to get in the wrong conclusion. So therefore, as people creating those diagrams, we need to be fully aware about deceptive graphs so that we can avoid it. So if you are the one interpreting somebody's chart, you also need to pay attention on those deceptive points to make sure you are not be misleading by the deceptive graphs. So I'm going to show you several arrows, and you need to fully understand those arrows in order to do your homework correctly. Okay, so the arrow 1 is called a non-zero origin. So as you look at this two diagram below, so they both are indicating the same diagram. So both of them are for the same diagram, based on the same data. But the main difference, okay, so the main difference is that pay attention on where the bar started. So the first diagram, the bar started from 2.1 minutes, and then the second bar is starting from 0. Okay, based on the first bar, the bar chart, and you will feel, oh, there is a big increase on the minutes, the length of the cell phone calls, right? You can see the differences between bars very obvious. However, if you actually including the 0 or your origin in your chart, you will notice that, hey, the change is not that obviously. So by not including the 0 starting from the middle of your bar, you are exaggerating the differences between the bars. Okay, so here we call it non-zero origin. So when you're creating the chart, always want to starting from 0 to preventing this kind of deceptive chart. Okay, so you need to check every chart whether they starting from 0. So a non-zero origin will exaggerate the trend, and so as you can see here. What is the second arrow? It's called elastic graph proportions. Again, the two diagrams on the bottom, they are exactly the same chart. However, the difference is the first chart, they are making the time horizon stretch longer, so make the chart like a rectangle. And then the second chart, they condense this horizontal axis, make it more like a square. So if you focus on the first stretch the chart, and you will see that the dollar per month spent on the cell phone services is slowly go up, right? But if you focus on the square chart and you feel, wow, it's skyrocketing, the price is skyrocketing, right? So that is called the elastic graph proportions. So we want to keep the aspect ratio width and height below 2. So basically the first chart is recommended so as not to exaggerating the graph. So by default, Excel does use an aspect ratio of 1.68, so that is recommended. So basically when you are using Excel to developing the diagram, and I don't recommend you to shrinking the length so that it become like exaggerating the trend. Okay, so this is the second arrow you might face. Double check if your length and width are following this below 2.0 recommendation. Number 3, dramatic titles, distracting art, and perplexing depth. Okay, so in our learning, we said that for the bar chart, we are recommending the 2D chart instead of 3D. Because 3D bar chart is really hard to read and usually don't give us additional information. On the contrary, the 3D chart will misleading our interpretation. And so as you can see, the right and the right hand side and the left hand side, left and the right hand side are showing the same data. But for the left hand side, we are including some distracting chart, and also we are using the 3D, which is really hard to read. And when you see the left hand side, you won't feel like 2000 bar is much higher than the 2005, right? But when you actually look at the right hand side, which only showing the useful information, and you will notice that, hey, the 2000 and 2005 are almost exactly the same height, but somehow in the 3D chart, it makes you look very different, right? So that's why you want a title should be short but adequate for the purpose, right? And then the second is avoid image that can distract the reader or impact an emotional slant. And the AD chart introduced further, the 3D chart A 3D chart introduces further ambiguity in reading the bar height. Again, don't use 3D chart. Okay, don't use 3D chart. Fourth, unclear definition or scales. And so if you are not labeling your vertical and horizontal axis, nobody can view it. And also as you're labeling it, you also want to include in the measurement unit. Sometimes it's measured by dollars, sometimes they measure by $1 billion. Can you imagine you missing that $1 million measurement unit on your chart, and people will misreading your chart, right? And for maximum clarity in the bar chart, label each bar with its numerical value as well, so people can actually read the bar. And so the fifth arrow can be the vague source. And so when you are getting the data and creating the chart, it's kind of very helpful to citing where is your data source, because you don't want people just creating the fake data and creating the fake chart. So it is many times people forget about that. So you want to make sure if you're possible, you want to citing the data source so that people can replicate your result, and also try to checking your visualization, go back to look at the original data source. Okay, the arrow 6 called the complex graphs. Okay, so the complicated visual displays make the reader work harder. Keep your main object in mind. So like this diagram, right? We have so many legends, and then the pie itself actually ended up very unclear, and we have graph. So it's just too many things going on. And as I look at this chart, I have no idea what kind of insight I should get out of it. The main reason is because it's a very complex graph. So how can you improve it? Several things you can do, right? You're going to delete those graphs. Instead of 3D chart, you should convert it to a 2D chart so that you are actually able to get an insight directly. And the arrow 7 is estimate data. So in the spirit of the zeal to include the latest figure, the last few data points in the time series are often estimated at a minimum. Estimate point should be noted. So if you do including some estimated data, then you should be noted in your data. So like Federal Reserve, they do forecasting based on historical data. So what they did is they do the line chart, and for the part they are forecasting, they use the dashed line versus the solid line, so that people will know, hey, the last segment is the forecasted or estimated data. It's not the actual historical data. So you should do the same thing. If your data does including some kind of estimated data, you want to call it out or use different way to label them. And then the arrow 8 called the area trick. So as you can see the picture below, and the left hand side is considered as a deceptive because what happened, they tried to creating the bar chart, right? As we mentioned in the class, for each bar the width should be the same, but as you can see on the left, the deceptive chart, they are actually making it wider and wider. It just makes you feel the last 2020, the million of the dollar they are spending way more. But actually it's not the case, right? Or the $2,000 spent way less. That's what we try to emphasize when you're creating the bar chart, and each bar's width should be the same so that you make sure each bar can be comparable. Versus now on the left hand side, that deceptive chart, you really feel from 2000 to 2020, the physician's salary are grow dramatically, but that's not the case, right? This is called an area trick. So one of the most pernicious visual trick is simultaneously enlarging the width of the bars as their height increases, so the bar area misstates the true portion. So like the replacing graph bar with a figure like human beings, corn, or gas pump. Okay, now let's look at a practice question to make sure you fully understand the 9 characteristics of the deceptive chart. Okay, so on this diagram, you are able to see the source of the medical errors. So like adverse drug effect, surgical incident, patient falls, etc. Okay, so now the question is, what kind of display this is? Okay, so a few minutes. So this is the bar chart, right? So it's a bar chart, but it's not just a single bar chart. It's the bar chart with 3D effect, right? So you can see the 3D bars. So as I'm saying this, some student already, hey, 3D chart, we don't like it. You're right. So we're going to answer that question later. And next, identify its strength using the tips and the checklist shown in this chapter. So remember, we already talked about, hey, what is the, if you try to answer this question, let me go back to the good thing. We talked about tips for effective table, right? We're talking about, we also talked about the effective bar chart. So basically, to answer that question, you need to use the information from our PowerPoint here, also from your textbook as well. Okay, so now let's go back to look at this question again. Okay, identify strength using the tips and the checklist shown in this chapter. So what this one is doing good. So they are doing good because each bar, the length, right, the width are the same and the height is the same. So that means they have they didn't using the size, the large areas to showing the data. So another thing this one is good is if you look at the ratio, right? The vertical and the horizontal, right? The width and the length, it's about less than 2. So therefore, we call the good proportion. So the proportion chart is very good. So we can read it very easily without feeling it's a distraction, right? And then the second is we don't see any weird pictures, right? They just literally pure chart. So we don't see any distracting pictures. Okay, no distracting pictures. But what is not this chart doing well, right? They didn't labels. So what is this horizontal axis? This horizontal axis actually mean? Are they frequencies? Or they are percent frequency, so they didn't label. And then they also didn't label this vertical axis. And then the title called the source of the mathematical error. That's why it took me a little bit time to figure out what this is about. So this title is very confusing. What is the source of the mathematical error, right? So are you counting how many error they make per week? I don't know. So it's very confusing. And also it doesn't telling us the source, right? So it didn't do really well. So as I already mentioned, so next question identifies weakness. So the weakness including didn't label the vertical and the horizontal axis. And also it is like 3D. We already mentioned we don't recommend any 3D for a bar chart and a pie chart. And also the title is very confusing. Okay, the title is very confusing. Okay, so now how can you suggest? So the suggestion would be adding the labels, right? Your vertical and horizontal axis, rename the titles, and changing the 3D chart to a 2D chart. And also there's one little thing, I don't know if you guys noticed it, and that is the bar chart is not starting from 0, so it's starting from 12, right? So therefore we should extending this horizontal axis so that it can starting from 0, because at this point the gap we see here might be exaggerated. Okay, so this is the end of this chapter. Hopefully after you're learning this, you know how to do a good visualization, and also make sure follow the computer skill lectures to practice. Make sure you are able to creating those chart and the tables.